Welcome to another episode of Agentic AI, the future of intelligent systems. As Agentic AI moves from experimentation into production systems, a new layer of engineering maturity is beginning to surface. In the early days, most discussions centered around model capability, orchestration frameworks, reasoning depth, and infrastructure scale. Those conversations were necessary. They helped us understand what was possible. But as agents become persistent, tool connected, and embedded into real workflows, another dimension becomes increasingly important. It is quieter, less visible, yet foundational to long term sustainability. That dimension is technical debt, not in the traditional sense of legacy code or outdated frameworks, but in how intelligent systems evolve over time. Agentic AI systems do not remain static. Prompts evolve, instructions get refined, edge cases are patched, constraints are added. What begins as a clean design slowly becomes layered with adjustments. Unlike traditional code, prompts do not fail compilation when complexity increases. They continue to run, but clarity can gradually reduce. Behavioral intent becomes harder to trace. Small modifications accumulate into architectural ambiguity. This is one form of hidden technical debt. Another emerges in memory design. Persistent agents rely on stored context to operate effectively. Memory, when thoughtfully structured, improves continuity and personalization. But without lifecycle discipline, memory stores expand, irrelevant context remains, outdated assumptions are preserved, rare events receive unintended weight. Over time, memory shifts from structured recall to generalized accumulation. The system still functions, but signal to noise ratios subtly change. Tool integration introduces another layer. Agents depend on API, services, and external systems. As those tools evolve, new parameters, new response formats, new edge cases, the reasoning chains that call them may not evolve with the same rigor. Retry logic expands, fallback strategies multiply, token usage grows invisibly. From the outside, the system appears stable. Internally, however, reasoning paths become longer and less predictable. Retry loops deserve particular attention. An agent that attempts, reevaluates, reformulates, and tries again is demonstrating resilience, but each additional reasoning pass consumes computation. What looks like a single response to a user may involve multiple internal iterations. Without observability into these cycles, cost, latency, and energy consumption expand without deliberate design choice. The architecture has not failed, it has simply grown. In multi agent systems, dependencies introduce further complexity. One agent's refinement affects another's reasoning chain, planner adjustments influence researcher outputs, validator constraints shape downstream behavior. These relationships are not deterministic service calls, they are probabilistic reasoning interactions. As systems scale, managing these cognitive dependencies becomes as important as managing microservices once was. Observability is often assumed to solve this. Many enterprises log token counts, latency, and request volumes. Yet deeper metrics, reasoning depth per decision, retry frequency, memory injection growth, tool call amplification, are rarely measured. Without this visibility, technical debt does not appear as failure. It appears as gradual drift. And drift, over time, reshapes systems. What makes this important is not risk, but sustainability. Agentic systems are increasingly embedded in approval flows, content generation, analytics pipelines, and operational automation. When complexity accumulates quietly, predictability decreases incrementally, cost structures shift, carbon footprints expand, debugging cycles lengthen. None of this happens abruptly, it happens gradually. The next phase of agentic AI maturity will not be defined by adding more intelligence. It will be defined by managing existing intelligence with discipline. Prompt version control will become standard practice. Memory lifecycle design will require explicit boundaries. Tool contracts will demand structured validation. Retry behavior will need budgeting. Cognitive observability will become an architectural layer, not an afterthought. This is not a correction phase, it is a natural evolution. Every technological wave experiences an expansion stage followed by refinement. In the agentic era, refinement means understanding that intelligence itself can accumulate structural complexity. The organizations that build durable systems will be those that treat reasoning flows with the same rigor once applied to API, databases, and distributed systems. They will prioritize clarity over improvisation, constraints over excess, deliberate architecture over incremental patching. Agentic remains one of the most transformative shifts in computing, but transformation at scale requires stewardship. This was episode 80 of Agentic AI, the future of intelligent systems. Till next time, keep building intelligent systems, lean, disciplined, and designed for long term clarity.